In this particular problem, we are going to perform thermal analysis of a solenoid. What happens? This particular solenoid has in a cast iron core with polyethylene insulator, and then it is a copper coil surrounding it. And then there is a fixed based plate which is made out of structural steel. So what happens? We are going to have a fixed temperature here. We are going to have a convection condition on surfaces, and we are going to have an internal heat generation in the core, and we are also going to find out what is the heat transfer or what is the temperature distribution inside this particular solenoid. And also we are going to plot the variation of temperature along the width of this solenoid using Ansys workbench.
Now we have opened Ansys Workbench. Take this steady state thermal and place it on the project schematic. And go to engineering data. Now go to engineering data sources and select general materials library and search for copper alloy, and also select this grey cast iron and then polythene, and close this engineering data. Now just right click on the geometry, import geometry, and select this particular solenoid. Now double click on the model cell in order to open Ansys Mechanical. Now set up the materials. So for bracket, the material is structural steel. For the core, the material is cast iron. And for the insulator, the material is polythene. And finally for this coil, the material is copper alloy. Then right click and generate mesh. Then apply the boundary conditions, right click, insert, and select this particular internal heat generation option. And select this core and press apply. Give the magnitude value of 0.01. Then right click, insert, temperature, and select this selection toolbar and select this phase and apply, and give the temperature value 25 degree. Now right click, insert, and select convection and select all the top faces and apply. Here the convection is going to take place through the top surface, and the film coefficient is 5e minus 5 watt per meter square degree centigrade, and then ambient temperature value is 25 degree centigrade. Now for this plate we give a perfectly insulated condition on the other three sides, so that means no heat can enter or no heat can go out through this particular boundary condition. Now select this perfectly insulated boundary condition and select these three faces and then apply. Now right click and solve it. Now right click, insert, go to thermal, select temperature and right click and evaluate the result, and see the maximum temperature is at the core of this particular insulator. Now we need to create a path, so we can select any edge to create a path. Now create two coordinate systems and place a path between origins of those two coordinate systems. For that, go to coordinate system, insert, coordinate system, and instead of defined by geometry selection, change it to global coordinates. And now give the values of its origin, give 23, 50 and 4 mm. So right click, insert coordinate system, and now define it by to global coordinates and give 23, 50 and 38. Now go to model branch and select construction geometry and select a path, and change the start coordinate system from global coordinate system to the coordinate system 1, which I have created now, and change the ending coordinate system to coordinate system 2. And now see a path has been generated between these two sides of the solenoid. Now go to the solution, insert, go to thermal and select temperature, and change this geometry selection to path, and select this path and evaluate all the results. Here a graph has been shown As the length is going this side, the temperature of variation is shown on the y-axis. So this is how we can perform a coupled thermal analysis where two or more different modes of heat transfer using Ansys workbench.